Hello students, in lesson number 8, motion, let's move further. Now, today we are going to learn about the graphical representation of motion. When we have defined the motion, we have learned some of the terms like distance, displacement, speed, velocity, acceleration. So these are the enough terms to represent the motion, okay, which is necessary to describe motion. But now if we want to represent the motion in graphical form, because we know that graph always gives more information. Okay, so without going into the much detailed data, if the data is represented in graph, we can simply get the idea about the motion with the shape of the graph. Okay, so by simply a line graph, okay, the graph will be is always of the form line, always in a line form. So by a line, the motion is described, and by simply the shape of the graph we can determine whether the object is moving or not, is moving with uniform motion or non-uniform motion, right? So this basic idea about the motion can be obtained from the shape of the graph. So mainly the graphs are of two types. If you remember the graph is generally consist of two lines, right? The horizontal line represents the x-axis and the vertical line represents the y-axis. And when these two lines are exactly at 90 degree with each other. Okay, they intersect each other at 90 degree. And the point of intersection, when these two lines intersect, that point is known as the origin. So this basic idea you need to remember. Generally, and on this graph, what we will represent? We will represent distance, speed, velocity, and time. Time is very much necessary because motion is always with respect to time only. When we represent motion, we start the motion, start this idea with the time only, because at this time the object is here and after some time the object is at another point. So with respect to time only the motion can be represented. So time is very important quantity in representation of motion. Okay, so this basic quantity, distance, displacement, speed, velocity, and time, this is represented on a graph. Okay, so mainly there are two types of graph to represent the motion. First one is distance time graph, okay, and velocity time graph. Distance means how distance changes with respect to time, that is distance time graph, and velocity time means how velocity or speed changes with time. Okay, that represents the velocity time graph. First one, we will see the detail of this graph. First one, distance time graph, which simply noted as D arrow T, that means D versus time graph. Okay, so this symbol represents that the graph is between distance and time. Distance versus time simply means distance will change accordingly with respect to time. Okay, so the independent quantity will be always on the x-axis. Time is independent. Time is not depending on anyone. Okay. So independent quantity will be on x-axis. So at x-axis, I am representing time. And dependent quantity will be on y-axis. So here in motion, the distance will be changing with respect to time. Okay. So distance will be on the y-axis. Distance are represented on y-axis. And so this simply represents the distance versus time graph. Now, according to the data, let us say, I am taking one example, one object at time t is equal to 0. See, on x-axis it gives the time, on y-axis it gives the distance. I am taking that one object at time t is equal to 0. This is origin O, where x and y is 0. So at time t is equal to 0, the object is at, this is the shape of the graph. It is a straight line like this. So the object at time t is equal to 0, it is at 20 distance. Okay, this is our observation. We are observing the object at 20 meter distance from some reference point. Now, after 1 second, we are again measuring the distance. So, at 1 second, the object is still at 20 meter. After 1 second, at 2 seconds, the object is still at 20 meter. After 1 second, at 3, the object is still 20 meter. At 4, the object is still 20 meter. At 5 seconds, object is still at 20 meter. So understand here, the time is passing, but the distance remains constant. It is not changing. It remains 20 only. So if the d versus t graph, that means distance versus time graph, is a straight line parallel to x-axis, see, it is parallel to x-axis. So if the shape of the graph is like this, if the graph is a straight line parallel to x-axis, then what can we say? That distance is not changing. If the distance is not changing with time, then the object is at rest, or we can say it is at stationary. So simply by looking at the graph, by the shape of the graph, we can say that the object is at rest. Okay, why it is at rest? Understand very carefully, because distance is not changing with time. The time is passing 1 second, 2 second, 3 second, 4 second. On x-axis, as we go further, the time will pass, but distance remains constant. So this shape will represent the stationary object. Now, second one. If the distance, same way, distance on y-axis, time on x-axis. And if now the shape of the graph is different. If the straight line, it pass to the origin, or it intersects x and y axis both. If it is a slant line it is, then what it represents, let us understand this. At time t is equal to 0, okay, this is our graph. This line represents our motion of the object. So at time t is equal to 0, distance is also 0. So it means it is at some O point, some reference point. Now at 1 second, the object reaches to 5. Okay, we always get the values based on depending on the line. Okay, so at 1 second, the object is at 5 meter distance. That means object has traveled to 0 to 5. Now after 1 second, at 2, the object reaches to 10 meter distance. After 1 second, the object reaches to 15 meter. After 1 second, the object reaches to 20 meter. So at every equal interval of time, the object travels some distance. Equal distance, 5 meter distance increases. Okay. So here we can simply say that the interpretation of the graph is like this, that at every equal interval of time, the object travels the equal distance. Okay, we are getting this distance from the respective value on y-axis. Okay, at x-axis 1, distance at 5. X-axis 2 second, distance will be 10. X-axis 3 second, distance is 50. X-axis 4 second, distance is 20. So at 1 second, the object travels 5 meter distance. It means that the distance changes with time. Okay, the slanting line represents the distance is changing with time, and it is equal in equal interval of time. So that will be the uniform motion. If you remember the definition for uniform motion. So if d versus time graph, distance versus time graph is a line intersecting x-axis and y-axis both, then the object moves with uniform speed. Now it is not at rest because distance is changing. It is not constant like this. Okay, it is same as 20 in this graph, but it is now changing with time. At every point, the distance is different on the line. Then that kind of graph represents the uniform motion. The object travels with a uniform speed, and we can find the speed also. If the data is given on the graph, x-axis and y-axis numbers are given, then we can find speed also. Speed is nothing but the distance traveled upon time taken. So here, let us take any 2 points. Okay, let us say A and B point. From between these 2 points, how much speed of the object is there? So I'm choosing this 2 point A and B and on this line, and I'm taking one another point C will make this triangle A, B and C. So I want to find that how much distance the object has traveled from A to B. When it travels from A to B, how much distance it has traveled. And to travel this distance, how much time it has taken. Simply, if I want distance, then I want to go to y-axis. And if I want time, I have to go to x-axis. So between these 2 points, A point represents the d1 distance, B point represents d2 distance. So how much distance the object has traveled from A to B? Simply d1 to d2. And how A, the object is at time t1 and it reaches to B at time t2. So at t1 time, the object is at d1. At t2 time, the object is at d2. So between this AB point, between these 2 points, the object has traveled d2 minus d1 distance and between the time t1 to t2. So speed is equal to distance traveled upon time taken. The distance traveled here is d2 minus d1 and the time taken is t2 minus t1. Right? So this formula, okay, so this d2 minus d1 is represented by bc and T2 minus T1 is represented as AC. So BC upon AC. BC upon AC will give the speed. Okay, so numerator has distance dimension and denominator has time. Distance upon time is nothing but the speed. So this value will give the speed. So if the data is given on the graph, we can simply find the speed of the object also. And any point we can choose because it is a uniform motion, the speed will be constant. So between any 2 points, if whatever point we choose, the speed of the object will be same. Okay, so any random 2 point you can choose, and by taking distance from y, time from t, time from x-axis, you can find the speed by putting the value in the formula. Now third, if the distance versus time graph, okay, y-axis represents the distance, x-axis represents the time. If the distance is not a line, but if it is a curve, if the distance versus time graph is a non-linear graph, that means if it is a curve, then the object moves with a non-uniform speed. You can see that the object in equal interval of time, the object has not traveled. Here, very less distance, but here very much distance is traveled. So it represents the non-uniform motion. Okay. So this kind of versus interpretation of distance versus time graph is that by simply seeing the shape of the graph, we can we can describe the motion of the object. Further, in the velocity versus time graph, we are taking velocity and time. Okay. So time is independent quantity. Velocity will change with time. Okay. So velocity will be the depending quantity. So velocity we will represent on y-axis and time will be represented on x-axis. So velocity versus time graph, how it will be represented? Simply the interpretation of graph will always be with respect to time. We have to change how with time the graph changes, right? So first one, velocity versus time graph, which also represented as v versus t graph. So first one, y-axis represents v, which is in meter per second. Standard unit is meter per second. So meter per second it will be represented. X-axis will give time in second. So the graph is like this. It is a straight line parallel to x-axis. What is the meaning of this? We can interpret it like this. At time t is equal to 0, the velocity initially the initial point of graph is this one. So 15 meter per second. It means that at time t is equal to 0, the speed, the velocity of the object is 15 meter per second. After 1 second, the velocity still remains 15 meter per second. After 1 second, the velocity still remains 15 meter per second. After 1 second, the velocity still remains the 15 meter per second. So as the time passing, but the velocity remains constant, not increasing, not decreasing. Okay? The value is constant on the line. This means if the graph is a straight line, where v versus p graph is a line parallel to x-axis, then the object moves with uniform speed. The speed is constant for this graph. It means that this parallel to x-axis line for velocity versus time graph represents the uniform speed of motion. Right? The speed is constant. Okay? The object will travel with constant speed. So, okay, so there is a difference between distance versus time graph and velocity versus time graph. The interpretations are different. Okay, so parallel line will represent uniform motion for velocity versus time graph. Now, interesting fact is that we can find the distance traveled from this velocity versus time graph. Okay? From distance versus time graph, we can find the velocity, the speed. Now, from velocity versus time graph, we can also find distance. Okay? How we can find the distance? See, we have speed is equal to distance upon time. This simple formula we have. Now, if the t from the denominator goes to that side, then it will be multiplication. So, v into t is equal to d. So, distance is equal to v into t. That means distance is equal to speed multiplied with time. Here, in this graph, we are getting speed from y-axis and time from x-axis. If we simply multiply velocity versus time, velocity with time, then it will give velocity with time will give distance. So for this case, let us say I want to find the distance traveled by the object from A point to B point. Let us say this. Okay, the object is traveling with uniform motion and we want to find the distance traveled. So at A point, let us say the time is t1. At B point, the time is t2. So between this two time, t2 minus t1, this time interval, how much distance the object has traveled. Distance will be obtained by v into t, velocity into time. So distance traveled by an object d is equal to velocity. For this, we are getting from y-axis. So this point gives the velocity. That means AC we are getting the velocity, and time will get from x-axis. So CD will be the time. So simply distance is equal to AC into CD, which is nothing but the area of rectangle ABCD. Right? ABDC. Sorry, it is ABDC. So by getting the area of rectangle, which gives AC into CD, which gives actually AC gives velocity and CD gives time. So it is nothing but the speed into time. That's why speed into time is distance. That's why this quantity is distance. So by the under the graph will give the distance traveled by the object. This is very interesting point. Now second one, if the graph of velocity versus time is a straight line passing through the origin or intersecting y and x-axis both. If v versus time graph is a line intersecting x-axis and y-axis both, what do we interpret this? We can interpret like this. See, at time t is equal to 0, the speed is 0 because at origin both y and x are 0. Now at 1 second, the object speed is 5 meter per second. At 2 seconds, the object speed is 10 meter per second. At 3 seconds, the object speed is 15 meter per second. At 4 seconds, the object speed is 20 meter per second. At each equal interval of time, the speed increases as the graph is like this. The speed increases for every point on the graph. So the speed increases and the change of speed is see at every 1 second there is an increase of 5 meter per second. Right? So the change is constant. So it is the accelerated motion as the velocity changes. But the object moves with uniform acceleration, means acceleration is same. Okay? Same means there is a change in speed, change in velocity, but the change is same. Every time there is a change of 5. Right? At every 1 second, there is a change of 5 meter per second speed. So the change is same, that's why acceleration is same. So that is called the uniform acceleration. And we can find the uniform from this point. A is equal to acceleration, we have change in velocity upon time taken. So between any 2 points, we can get the change in velocity. See, from from A to B, let us see A has the velocity, that is initial velocity u, and B point has the velocity v, final velocity, and the time we are getting from x-axis, that is t1 and t2. So, the change in velocity will give v minus u, and the time interval will be t2 minus t1. So, by using this formula, v minus u will represent the vc, and t2 minus t1 represents ac in the triangle ABC. So, by this formula, we can get the acceleration from the graph if the data is given. Okay, and distance, we know that we can get the distance by the area enclosed by the graph. Area under the graph will be the distance. Okay, and third one, understand this very carefully. Y-axis represents v, x-axis represents time. If the graph is this line, but it is slanting on opposite side. See, it is slanting on this side. Now it is slanting, but in opposite side. So how do we represent it? Represent it. At time t is equal to 0, the object velocity is 50. At 1, the object speed decreases. At 2, the object speed decreases. At 3, decreases. At 4, the object velocity becomes 0 because y-axis becomes 0 here. It means that the speed decreases with time, and that we are calling it retarded motion. And if the graph of velocity versus time is uneven, okay, it is a random or curve or not, it's an uneven line, then it will be a non-uniform motion. So this is how the interpretation of graph is that we can simply identify the motion of object by seeing the shape of the graph. It is very important topic. So read very carefully and interpret it very carefully. Okay. So still read up to this, and if you still have any doubts, you can ask me. Thank you.